Welcome to discussion 12. In today's discussion, we'll be focusing on section 3.1 on derivative rules and 3.2 on the product and quotient rules. In this video, we'll talk about recognizing which derivative rule applies. So we have learned about three main derivative rules. So recall that the power rule says that the derivative, d dx, derivative of x to the n is n times x to the n minus 1. So the power, the n comes down, and then we subtract 1 from the power. And n is any real number here. But it's not a variable, so it doesn't work for something like x to the x. It's got to be my variable x in the base, and then a real number, a constant in the exponent. All right, so next, the product rule. So this is if I have the derivative, d dx, of two functions multiplied, f of x times g of x. This is the product of two functions. And the product rule says, okay, that derivative is going to be the first function, f of x, times the derivative of the second, plus the second function, g of x, times the derivative of the first, derivative of f of x. Remember, this is one of the chants that I had us all do in our lecture videos on product rule. It's the first function times the derivative of the second plus the second function times the derivative of the first. All right, and then we have the quotient rule. So the quotient rule is for the derivative of two functions divided by each other, f of x over g of x. This is called the quotient of two functions. Okay, and the quotient rule says low d high. So remember, the bottom I sometimes call low, and the top I call high. Quotient rule says low d high. So that's low. D high means derivative of the top. D high minus high d low. So minus high, which is f of x, that's the top function. D low, derivative of the bottom function. All over low squared. So all over that g of x being squared. All right, so let's do some practice problems. So these are from worksheet 6. And I want to have you try parts A, B, C, D, and H first for about 8 minutes. Some of these will be very quick. So if you do finish all of them in the 8 minutes, then try E, F, and G. 4, 3, 2, 1, pause the video and try these questions for about 8 minutes. Alrighty, so hopefully you did that. Hopefully you paused it and tried them for about 8 minutes. Let's talk about them together. So for part A, I need to take the derivative of x squared root x. It'll be helpful if I can simplify it first. Even though this is the product of two functions, I don't need product rule if I can simplify it first and get it to a form where I don't need product rule. So this is x squared, root x is x to the 1/2. And now when I'm multiplying two things like this with the same base, I add the powers. So that'll give me x to the 5/2 when I add the 2 to the 1/2. Okay. And now this is really nice for the derivative. The derivative of x to the 5/2 is just a simple power rule. The power comes down, the 5/2 comes down, and I subtract 1 from the exponent to get x to the 3/2. And that's it. Notice that that's definitely quicker than if I had to do this using the product rule. Okay, so for B, let's see, I have, function divided by function, and I can do this, well, let me write this as d dx of 2/3x plus 1. The rule I'm going to need is the quotient rule. We will need quotient rule for this. And when we do quotient rule, it says we get the bottom function, low, 3x plus 1 d high, so times the derivative of the top, 2, derivative of 2, and then minus high, minus the top function, d low, so times the derivative of the bottom, 3x plus 1, all over the bottom squared, all over low squared. 3x plus 1 squared. Let's write that a little better. This one is 3x plus 1. Okay, so now if we evaluate these derivatives, the derivative of 2 is 0, because 2 is a constant. Okay, so that leaves us with the minus 2. The derivative of 3x is 3. The derivative of 1 is 0, because that's a constant. So we have this over 3x plus 1 squared, which is just -6, over 3x plus 1 squared. And that is our answer. That is our derivative. So let's do part C. So in C, it's a similar function, just the denominator is a little bit more complicated. We have 2x over 3x squared plus 1 squared. Okay, so we're taking the derivative of this whole thing. All right, so function over a function makes us think quotient rule. When we do quotient rule, at some point I'm going to need to take the derivative of the bottom. And to do the derivative of that, I can't just use power rule and bring that 2 down and subtract a 1. Because that works if I have x squared. It doesn't work if I have something more complicated, something like stuff squared. Okay, so it's going to be helpful if, before I get into this derivative, if on the denominator, because I have that whole thing squared, let's just expand it. That thing times itself will be 9x to the 4th plus 6x squared plus 1. If you actually multiply it by itself and FOIL out, you will get that. Okay, so from here, now this is just going to be quotient rule. Now we need quotient rule. We're going to need some quotient rule, and because that's going to be so similar to the last part, I'm going to leave this for you for practice. I'm going to leave this for you. All right, and let's move on to part D. So remember D was asking us to find the derivative of e to the x over 3. And with this, I have a function over a function, the 3 technically. So I might think quotient rule, and I could do quotient rule with this and get a right answer. But there's a way to do it without quotient rule. That's going to be quicker. And that's to realize that this 3 on the bottom, that's a constant. And I can move that, because it's constant multiplying my function, I can move it in front as a 1/3. I get that 1/3 times the derivative of e to the x. I'm only allowed to move it in front of the derivative because it's a constant. And now I don't need quotient rule. This is going to be 1/3 times the derivative of e to the x, which is just e to the x. So we get 1/3 e to the x. Let's just write that as 1/3 e to the x, and that is it. That is our derivative. No quotient rule needed. All right, finally, let's look at h. H was the derivative of 2 over x e to the x. So for this, I could move the 2 in front of this, because the 2 is a constant, but that'll leave me with 1 over x e to the x. And the x e to the x is on the denominator, so I can't take the derivative of that, at least based on what I know, without the quotient rule. So we will need the quotient rule for this. And if we do that, we'll get low d high. So low is x e to the x. D high, so derivative of 2, minus high, minus 2. D low, so times the derivative of the bottom, derivative of x e to the x. And then this whole thing over the bottom squared, over low squared, x e to the x squared. Okay, so as I get more comfortable with these, I will start to just work out these derivatives, like the derivative of 2 and the derivative of x e to the x, all in one step. So I know I set it up like this, but let's just replace these derivatives with what they're going to equal. The derivative of 2 is just 0. And for the derivative of the x e to the x, for this, we are going to need the product rule. Okay, so let's do the derivative of x e to the x using the product rule. So the product rule says I'll get the first function, x, times the derivative of the second. So times the derivative of the second, and then plus the second, which is e to the x, times the derivative of the first. So times the derivative of that one. Okay. Simplifying this, 0 times something is 0. So we're left with minus 2. And then in brackets, we'll get x. Derivative of e to the x is e to the x. And then we get plus e to the x times derivative of 1 is 0. You know what? I miswrote something. This shouldn't have been derivative of 1. I just miswrote that. That should be the derivative of x, because my first function here was x. Okay, so we should be getting e to the x times the derivative of x, which is just 1, So I could just leave it like that, and then I get this all over that denominator squared, x e to the x squared. All right, and that is our answer. Let's do another practice problem. Let's look at question 7b from worksheet 5 from the previous worksheet. I want to compute the derivative of this function L of x, which equals x to the 2e plus e squared plus 2ex, this is e times x, and then plus e to the x minus 2 power. So pause the video and try this for 2 minutes. 4, 3, 2, 1, pause it and try this one for 2 minutes. Alrighty, so hopefully you did that. Hopefully you paused it and tried it for about 2 minutes. Let's talk about it together now. Okay, so if we get into this derivative, for x to the 2e, well, that's just x to some constant power. So this is power rule. I bring the power down, the 2e, and then I'll get x to the, subtract 1 from the power to get 2e minus 1. For e squared, keep in mind this is a constant. There is no variable in this. So the derivative of e squared is just going to be 0. So I'll get a plus 0, so we got to be careful with that. For the next term, we have 2e. 2e is a constant, and then times x. So the 2e is going to stay there, and that'll multiply by the derivative of x. The derivative of x is 1. All right, and for the last term, e to the x minus 2, I don't know how to take the derivative of that as it is. I know how to take the derivative of e to the x, but I don't know how to take the derivative of e to the something more complicated. Eventually, we'll learn a rule for the derivative of something like that, but right now, we don't have that. So we need to be able to simplify this somehow. And that's where exponent properties come into play. This is e to the x times e to the negative 2. Because with these, we would add these exponents to get x added to negative 2, and that gives me that x minus 2. Okay, and e to the negative 2, that is a constant. Multiplying my function e to the x. So let's write that constant in front, and that will multiply the derivative of e to the x, which is just e to the x. So that is the derivative of e to the x. And if I simplify, we get L prime of x equals 2e times x to the 2e minus 1 plus 2e, and then plus e to the negative 2 times e to the x. And that is our answer.